All right, welcome to Stage 6. My name is Aaron. I'm a solution architect here at AWS and I'm the MC for Stage 6 for today. So glad to have you here for Sec 304. I will start by saying, if you haven't got the app yet, please do. It's really great at getting you the calendar, the schedule, and kind of planning your way throughout the day. But then when you finish this session, there'll be you can click inside the event and you can give your survey, your feedback, and that's obviously really important to us. A few housekeeping things today. If you could turn your mobiles to silent, if you otherwise haven't, you probably won't be able to hear them, but maybe the speakers on the stage will, which could be a bit confusing. And put up your hand, or if you notice someone near you that their headphones aren't working, let them know to put their hand up and we'll endeavour to get round to you and obviously help you with your headphones. So today is going to be a great one. Sometimes the best defense is actually having a great offense, and I'm really interested to hear from Liang and Sam today around some of those strategies in security. So please, welcome to the stage, Liang and Sam. Guys.
Hey, we're going to have the clicker, I think. Yeah. Okay, good morning. So my name is Zhang, and I'm from AWS Enterprise Support as a Security Technical Account Manager. So I hope you're having a great time at Sydney Summit.
Hi, everyone. I'm Sam Zhang, a Security Specialist Technical Account Manager at AWS.
Okay, awesome. So we'll be going through the anti-ransomware strategies on the cloud. And there are 4 key parts of today's topic. So the first part is going to be looking at the trends that we're seeing, and then we'll provide some security controls and strategies around that. And then we'll start diving deeper into the phases of ransomware threat. So that is something inspired by probably something you've heard of called the cyber attack chain. And then after which, we'll go into the anti-ransomware walkthrough that Sam will provide for us. And then finally, we'll go over into the prevention, detection, response, and recovery strategies and guidelines in terms of anti-ransomware strategies, okay? So this is a fairly technical session, an advanced session, so familiarity with AWS core services like EC2, VPC, S3, and so on are to be expected to get the most value out of today's session, okay? And of course, ultimately, for many of my customers and organizations, the ultimate goal is ensuring high availability of systems and applications, and so high security of your systems and applications. So we want to keep this objective in mind as we dive down to the policies, down to the implementation guidance across these anti-ransomware strategies, okay?
Okay, so in Australia, ransomware remains a critical threat. Based on Australian government reports, in last financial year alone, there are hundreds of organizations were targeted. And with this number continue to rise. Well, the impact also very staggering. So basically, a simple ransomware event typically affects more than 168,000 individuals. Well, despite the high pressure, the Australian government stance is unwavering, never pay a ransom. And at AWS, security is not just a feature. It's actually everything we build. It's a fundamental to everything we build. When organizations like Australian government choose AWS to build their top secret cloud, it is because they trust our relentless effort to security. So a recent study also showed that AWS achieved more than 99%, 54%, 99.54% uptime across APAC, and we're at least 2.7 times less likely to experience an outage. Well, AWS is also the only cloud provider which is offering 3 or more geographically separated availability zones, and which is providing greater redundancy and protection.
So what are the common security challenges we have seen? So having run the Enterprise Support Security Improvement Program globally for more than 1,300 of our biggest customers, there are 3 key areas. All right, number 1 is to be able to map security policies specifically into security controls. So for example, you may not want external principals to have access to your S3 buckets or resources, and you may have that written in policy, but how do you implement them in controls? And then number 2 is in terms of threat detection coverage. So what we have seen here is that cloud workloads are ephemeral. So right now you could have 100 EC2 virtual servers, and then an hour later you have 1,000 of them. So as they are instantiated or as they are terminated, you want to ensure that monitoring kickstart not just more deeply down to the processes they are running within the operating system, but also more comprehensively across all of your workload type. And then finally, in terms of incident response capability, what we're seeing here is there is a gap in terms of being able to test and effectively respond to different types of ransomware events. So all in all, what we do recommend is to be able to run the security improvement program that has close to 300 security controls, and we will generate a security report for you with a list of prioritized action plan that can help you move to the next level of security maturity. Okay, so this is something that you can draw down from. So with that, we'll start diving deeper into each of the phases of the ransomware threat. And then from there, we are going to provide you specific security controls or policies that you can implement as part of enabling those preventive, detective, or response capabilities. So number one is reconnaissance. So what you can see here is the threat actor on the left. All right, so the first thing that they typically do is to enumerate for resources. So right in the center, this is where we want to ensure that parameter security is enabled down to the web application firewall rules. So we have CloudFront, which is AWS's CDN, and then in the center we have AWS Web Application Firewall, and then we have Shield Advanced, which is an anti-DDoS service. And then there are specific rules that we highly recommend that you turn on and enable. So the first rule is the rate-based rule. So this is something that we can stop the volumetric excessive access from a specific IP address or user agent hitting over specifically into your workloads. And then you can say set 3x, 4x against the average request. And number two is bad IP reputation. So we deploy honeypots across the internet. And what we're doing is when we uncover specific IP address that may be doing scanning across the internet, trying to look for open or accessible endpoints, those bad IP addresses are added into our managed rule, and you can block them out immediately. And number three is bot control. So we are seeing for a lot of the traffic into AWS right now, generally, more than 50% of those traffic are coming from bots. So what we recommend is the ability to discern between what are the good bots and what are the bad bots. And we do that automatically through reverse DNS, fingerprinting of the traffic, and then you can block those bad bots quickly using a bot control managed rule. Next up is specific endpoints. So as the threat actor are building up the blueprint of your site, what they are doing is they could be trying to figure out specific endpoints that may be more chargeable or more billable. So in that case, you can set scope down rules within AWS Web Application Firewall. So for example, in this case, it could be /SMS/2FA, and you can set them to a much lower request rate so they can block out those excessive requests once more, okay? Next up over here is for all origins, we highly recommend fronting them, all right, with CloudFront, with AWS Web Application Firewall, with AWS Shield Advanced. So what the threat actor on the left is doing here, they're trying to uncover direct access to the origin. So perhaps you have JavaScript, CSS, static content like images and so on. And those may be directly accessible into the S3 bucket. So what we want to recommend here is, again, to be able to block out the volumetric access using AWS Web Application Firewall rules, and then to restrict that using the S3 bucket policy so that it's only accessible from Amazon CloudFront. So all in all, for all internet-facing resources that you have, you can set policies or checks using AWS config, and to ensure that they're automatically assigned with an AWS Web Application Firewall web access control list. And then with that, you can set like the rules that we covered earlier, bad IP addresses, anonymous IP addresses, bot control to be able to pick up all this bad bot traffic, and you can begin the blocking and defense from there. So this will help you seamlessly integrate all these internet-facing applications with AWS Web Application Firewall. Next up, we have initial access and privilege escalation. So what we recommend here is to have Amazon GuardDuty runtime monitoring turned on. Anyone here already using GuardDuty? Can you put your hands up? Okay, quite a handful, great. So GuardDuty runtime monitoring is able to look at the OS level access, file access, directories, process ID, user ID, and all this different deeper information, including command line arguments. So what we're seeing is also the use of more native services to gain connection over into the target workload. So with command line arguments and runtime monitoring, we can say that, okay, someone is using, for example, RM, and they try to remove var locks, or they try to use, for example, Nmap to scan across the CIDR range and so on. So we can pick those up as signals and as GuardDuty findings. All right, so this can be automatically turned on, and as workloads are created or instantiated, the monitoring runs along with it automatically. All right, so pretty good service. Next up is we recommend turning on GuardDuty not just for your critical AWS accounts in the regions that you're operating in, but across all of your AWS accounts, across all of the regions, so that we can pick up anomalous behavior. So if someone decides to spin up 1,000 EC2 virtual servers in another region, you can pick that up as an anomalous behavior so that you're monitoring across all of your accounts, across all of the regions. And number two is to move away from persistent IAM user access key over into IAM roles or IAM roles anywhere. So IAM roles and IAM roles anywhere are automatically rotated credentials. They're temporary credentials, and it's going to be much easier for you to ensure that these temporary credentials do not have persistent access across all of your different AWS accounts. So this is an example over here. So someone trying to create an IAM user, and you can see here on the bottom right, there is an access deny picked up by GuardDuty. And this can also happen if you have two options, right? One is using service control policy to deny direct access into IAM, where they could possibly try to change the policies, they could try to create IAM users, and so on. And number two is you can have a common IAM policy that is deployed down to all of your users and roles that will deny direct access into IAM too, except for the IAM administrators or analysts. Next up, we have lateral movement. So diving deeper into runtime monitoring, what we are trying to do is to shift left as much as possible. And that means deeper insight into the workloads. So whether you're on Kubernetes, containers, EC2 virtual servers, we want to be able to pick up when a specific process is being executed. So in this case, we can pick up like the process ID, the user ID, the directory is executed in, the hash value, and so on. So we can pinpoint specifically what's going on within the workload. And then you can take specific action like being able to terminate that process rather than containing the entire workload, all right? The other great service here is the malware protection for EC2. So as GuardDuty picks up the security event, what it does for us is that it can automatically take a snapshot, and from there, we can scan it and look out for potential malicious software within it. So typically, software like that are stored inside /TMP. So we would scan into /TMP. If someone decides to download the Linux enumeration shell script, we can pick that up too, and then flag it out. And then you can introduce automation into the AWS environment. And then from the automation, you can decide to quarantine or to restore a clean copy of the EBS volume back to the workload. Next up, we have data exfiltration. So anyone heard of DNS tunneling or domain generation algorithm? Yeah? Okay, so great news. We have launched these two capabilities in Amazon Route 53 Resolver DNS Firewall. So we can look into the workload and see what the workload is running in terms of DNS queries and picked up DGA as well as DNS tunneling and flag them out for you as security events. And then at the same time, you can also decide to have inspection and to have blocking for specific domains. So typically, we do not allow direct access into domains like .xyz, .top domains, and you may be restricting them to only be accessible to AmazonAWS.com to pull patches or updates from the AWS sites. So you can do those restrictions from here. Last couple of phases, all right, account, data, lockout, and ransom. So we have a comprehensive S3 data protection plan. So on the most left here is what we call as the S3 protection. So if you require specifically for your more critical or sensitive S3 bucket, you can turn on S3 protection. So with that, we go down to the object level events. So say, for example, if a bad IP or a tall IP address hits into the object, we can flag that out as a gut duty finding for you. And then in the center, if you recall, we were covering malware protection for your EC2. Same thing here. So as objects are uploaded into the S3 bucket, we can do an automated scan. And then we can pick that up and say, hey, is there a malware found in that object? And then you can introduce automation to it to say, okay, you want to block direct get object to these objects that may have threats found in the metadata or key value pair. And then finally, extended threat detection. So this is something new, launched about 6 months back. This is where we are not just looking at the object level events, but what we are doing now is we're taking from numerous data sources like CloudTrail, and then we're correlating that across the AWS environment. So if someone with an anomalous IAM user or role behavior begins to enumerate S3 buckets, begins to update the S3 bucket policy to be more permissive and accessible to certain external principals, and then they try to go into the bucket itself to list down those objects, we can pick that up too. So this is the extended threat detection capability. And ultimately, right, this is an automated intelligent protection for a lot of your workloads that are backed up into, they're stored within the S3 environment. So all in all, covering the phases as well as a specific security implementation helps inform our prevention, detection, response, as well as recovery guidelines in terms of security strategies. Okay?
All right, thank you, Yang. So with that, let's put all the 7 different phases together and take a look at the walkthrough. So introducing Any Company FinTech. This is a fictitious company which is for education's purpose only. So in this presentation, so it's not reflecting any real-world company. So we assume Any Company FinTech is large FinTech company which has good large footprint in Australia and New Zealand. They need to follow Australian Prudential Regulation Authority, APRA, and the payment card industry data security standard, the PCI DSS regulations. Despite some guardrail in place, the Any Company FinTech recently experienced a ransomware event, which actually caused some unauthorized access and some system availability issue. This was actually caused due to a series of misconfiguration. Then you will quickly find out it's very easily to be addressed, and we could have prevented this one from happening at the very start. The whole thing did not happen over the night. It's actually a 9-day journey. From the day 1, where the threat actor observed an EC2 misconfiguration, where they established their first foothold, to the next phase, they spent 2 days, located a long-term credential with permissive access. To the next phase, day 4, day 5, they could find a less protected cross-con role, so allow them to come from staging environment to a production environment. And then from data discovery happened on day 6 and day 7, where the critical data was found and moved out. And everything finished on day 6 and day 8 and day 9, where the threat actor start to re-encrypt the data with their own key or lock the original owner of the data out. Now let's zoom into each of the phase and see what exactly had happened. Everything starts in the staging account. When a developer tries to test a new feature in the customer portal, and they spin up EC2 instance in the public subnet with the public IP associated to it directly. And what was worse, they were using instance metadata version 1, which is not having the strongest authentication approaches in place. And then they are granting an instance profile with a very powerful access, which is the full S3 access. In this case, threat actor could reach out to the EC2 directly with a correlated HTTP request, so they can visit instance metadata file, instance IMDS server, and then grab the temporary credential. This is how the threat actor get into the staging account at the very first place. However, this can be easily addressed by using IMDS v2. So without the valid token, the threat actor will not be able to retrieve the temporary credential. So in this case, we can start that from very beginning. Well, in this case, the threat actor actually succeed. So they're searching based on the full S3 access. Unfortunately, they actually found it as CSV file with a access key ID and a secret access key, which was left by a ex-developer, and it does come with the administrative access. So in that case, with the new permissive access, the threat actors start to search for some more valuable data. For example, they are looking for IAM objects and policies. And based on this naming convention in the custom managed IAM policy, they found that they could lead to from the staging environment to the production environment. And if we are zooming into the trusted policy of this cross-account access rule, we actually see that it's actually granting all the IAM principals in staging account. If they got permission to do so, they can assume to this role. OK, so next step, the threat actor will use the long-term credential to access from staging environment to the production environment. And from there, they're going to observe a bit of more valuable resources. For example, a S3 bucket storing RDS snapshots, or RDS and S3 bucket storing personal identifiable information. And since this is the deployment role, it has very powerful access as well. That is why threat actor could move the data out. Final stage, threat actors start to delete the object version and also delete RDS snapshots, and then re-encrypt the data. So the goal is to prevent original owner from being able to recover the data. With that, I'm going to hand over to Yang. So he's going to explain anti-ransomware strategy, and then we're going to revisit how this can be implemented, how we can improve any company fintech.
OK, so the first part is going to be on prevention. So prevention is key. And if we start from the top right corner, which is to eliminate static credentials. So this is moving away from IAM users and then moving into, for example, IAM roles anywhere, and at the same time to utilize AWS IAM Identity Center, or previously known as SSO. So with that, you can then centrally manage the access to all of your AWS accounts from a single identity management or operations account. And then with that, you also want to begin refining more of your existing policies. You also want to look out for excessive privileges that Sam was sharing. So if you recall, we have the S3 full access. Would you be able to tighten that down to specific resources? Would you be able to look out for not just star all star, right? All principals and all resources. But what about only allowing read access to specific IAM roles or certain roles that you define in your organization? And then on the top left corner, this is where we are looking at preventive controls using service control policy. So you do not allow someone to go to CloudTrail and be able to disable it, or be able to disable Guard Duty as a service that runs all the threat detection capabilities. And there's also going to be there's a new service, or a new feature that was launched several months back called Resource Control Policy that Sam will deep dive into later on. This is where, if you want to define a policy that restrict all external principal direct access into your, say, S3 bucket, you can do that. So even if someone goes into the S3 bucket, put up star, all principal, all access, with the resource control policy that you can deploy easily, either through Control Tower or you can write it on your own, you can block and stop all those access too. All right, so pretty powerful. In terms of detection, all right, so I know we cover a little more extensively on Guard Duty as a threat detection service. So on the left side, you have all these different workloads, and you're going to have variants of them, all right, different architectures, serverless, EC2, and so on and so forth. And you want to ensure that the protection plan that makes the most sense for those workloads in different accounts or organization units are enabled, and also using numerous security services like Macie for data discovery classification, Inspector for vulnerability management, and then they all aggregate right into the center from AWS Security Hub, right? Your cloud security posture management service that also aggregates all these security findings from numerous security services. And then all the way to the right, you can see here, we are doing investigation. So you'll be using services like Detective to build out the entire topology of the sequence of events. You're also using Security Lake so that you can query into specific events of timestamp and gather your evidences and artifacts from there. So who is already using Amazon Detective for threat investigation? Okay, some. All right, great. So Detective is a service that I see more and more of our customers utilizing. So on the left side, you have all these different security findings that are occurring. And then right in the center, it's doing the automated extraction of the information from CloudTrail, VPC flow logs, from your security findings, and then it builds out a behavior graph. So you can see that, let's say there is an IP address that is having anomalous behavior. You can pick that IP address, you can investigate on it, and see what other resources is it interacting with across your whole AWS account and environment. So pretty powerful service. And on the most right, this is where you can incorporate that into your security dashboard or operation center and say that, okay, we're running automated investigation here, we're investigating this specific IAM, Amazon resource name, and so on. So all those automated investigations can kickstart from detective service. In terms of response, so what we have seen some customers done is to codify the incident response playbook and its state into like a state management service, say DynamoDB in this example, and also to utilize all these detection services. So as the security event occurs, let's say there's a gut duty finding, what happens is that your automation kicks in, and it goes over into the data sources to extract those specific timestamps, those evidences for your security operations center analysts. So you're speeding up the investigation and the triage process. And then with that, it sends a notification to the security analyst or the security team. This is the evidence that we have collected automatically. And then these are the containment options that we have. Do you want to contain the workload? Do you want to take further investigation onto the adjacent or related entities, and so on? All right, so these are some of the automation that we have seen. And with this workflow example, you can implement those automation as well into your response environment. Next up, you have all of your workloads over here. And this is the part where you have your S3 buckets, your EBS volume, your EFS storage, and so on. And you can easily set up backup plans. So you can set up the automated plans to have clean copies of those snapshots. And then you can also send them over into a separate AWS account. And then with that, you can have your restoration effort that would have you enable and recover very quickly from any security events. Okay?
All right, so now with all this strategy in place, let's see what any company fintech could have done. First thing first, they should follow one architectural framework. So instead of placing the EC2 instance directly in the public subnet, we strongly recommend you to put that into private subnet and with the NAT gateway and ALB in the public subnet. Because with that, you will now have a chance to attach a AWS WAF ACL into the ALB. So in that case, when threat actor is sending some suspicious traffic, for example, this one is the server-side request, forgery request, it will actually getting denied at first place. And then, like we said earlier, we should use IMDS v2. You can use the AWS declarative policy, which is new type of policy feature that you can enforce all the newly created EC2 instance to have this new IMDS version. And then have a tighten S3 bucket access, so only grant necessary permissions as needed. Avoid of using long-term credential and do regular cleanup and auditing. For example, you can use a credential profile to do the manual auditing, or you can use IAM access analyzer to perform a continuous auditing and do the cleanup from there. Detection-wise, you can use guard duty. So that's going to pick up if someone is using the temporary credential of your EC2, but outside your account. In this case, guard duty will generate a high severity finding for you. Now let's take a look at the production account. So for such account which are hosting the mission critical data, first thing first, for any cross-con role, make sure it's very well tightened. Instead of giving all IAM principals at the account level to access to this role, make sure you are very specific to only the principal ARN that you're allowed to have access to. And then, since this is a fintech company, they need to follow the regulation. They need to store the PI data for a certain period of time, using object lock, which will prevent anyone from accidentally or unauthorized way to modify or delete your data. We talk about RCP. So in this case, how we can prevent, for example, someone to re-encrypt the data by using the key which I'm not on. In this case, RCP will be able to affect all the buckets inside your entire organization. And then the unauthorized re-encryption will fail. Next, another ICP will be super helpful if someone is calling S3 bucket API from untrusted network. So in this case, I only allow the people who are calling from my trusted VPC or trusted corp IP ranges. In this case, threat actor data moving out action will be denied. So anti-ransomware strategy is not just a random technical controls, it's actually a strategy I really highly suggest you take a picture of this because your application will be very different to any company fintech. So we want you to think about prevention, detection, and response strategy for every different phases in the ransomware threat lifecycle.
Yep, so with that, we have come to the end of the session, and we would really appreciate it if you can go over into the app and provide your feedback for today's session. We hope we have covered something useful, something interesting that you can implement in your organization. Myself and Sam will be here. We'll also be at the Ask an Expert booth area, so if you have any questions on AWS security, just feel free to come up. So thank you.
Thank you.